So earlier we discussed about EIGRP, a quick review of what we learned about EIGRP. Enhanced Interior Gateway Routing Protocol, that's what EIGRP stands for. And every protocol has got some metric. EIGRP also got 5 metrics actually, not just one. It has got 5 metric. The first metric, which is called as K1, K1 represents bandwidth on the link. Bandwidth on the link. K2 represents load on the link. K3 means the delay on the link. K4 means reliability of the link. K5 represents MTU, maximum transmission unit on the link. See, if you take any wire, these are the 5 things that will be there. Let's say you got a road. Instead of wire, let us think about a normal road where you go with your bike, with your scooter. Now, the road, if you take, the road has got a size, like 100 feet road. That is what here bandwidth means, bandwidth on the link. See, in that 100 feet road, how many people are going right now? How many people are going? If it is early morning, very less people. If it is somewhere around 8:30, people will be too much because they all go office and school. So load is going to be high. Load will be varying time to time, but bandwidth never changes. It's same 100 feet road. But load on the road will change. Midnight, sometimes no load at all. Empty, road is empty. No one, not even one e-car, because it's a night time. Road is empty, so no load. So load is a variable. Even in the network, not all the time data will be flowing through a wire. During office hours, of course, there will be a lot of traffic in the wire. But in the break time or during the holidays, there won't be any traffic coming on that wire. That is what the load means here, the amount of traffic that consumes the bandwidth, that is using the road. Now the delay also variable only, but here the delay is different. Here 100 feet road, assume 100 feet road, 100 kilometers. 100 kilometers in 100 feet road. Same 100 feet road, 100 kilometer airways. ஆகாயம் மார்க்கமாக போவதற்கும் சாலை மார்க்கமாக போவதற்கும் வித்தியாசம் உண்டு. When you go through airways, the time taken may be like 15 minutes. It won't take more than that. It won't take more than that. If landing and takeoff is clear enough, good road for takeoff and landing, no bad weathers, it won't take more than 15 minutes for 100 kilometer. See, Bangalore to Chennai, it takes hardly 30 minutes. Only 30 minutes, half an hour. If it is a big flight which can fly above 30 feet. Below 30 feet, there will be a lot of opposition forces, gravity and so on. And then it will be slightly delayed. Small flights will take 1 hour from Chennai to Bangalore. But over the road, it will take minimum 6 hours. Chennai to Bangalore. That is what this delay means. See, in airways, 15 minutes, fix it. In roadways, 6 hours fixed. Can you reduce the 6 hours? Can you go less than 6 hours? Not possible. Even if you have a very high speed bike, not possible. 100 kilometer less than 6 hours. That too in a normal public road. It's not a private road. You have signals to follow. You have a lot of things to consider. Village side, some buffaloes will cross the road. You need to apply the brake. So 6 hours. You cannot reduce the delay. So delay will be always there. See, you throw a stone. That stone falls somewhere, but there is a time taken to go to that place where the stone has fallen down from the place where you thrown it. Definitely there is some time, at least some microseconds when you throw the stone. Not microsecond, you will have more than seconds. I'm just giving you an example. In wire, it will take some microsecond, sometimes millisecond delay. Any wire you take, there will be delay. There will be a delay, fixed delay. You cannot change the delay. Delay can be more, but it cannot be reduced. Like I said, you cannot go less than 6 hours from Bangalore to Chennai on the road. It may take 9 hours if you go and sit in A to B on the way and have some nice coffee, with filter coffee with dosa. It may become 8 hours, but you cannot come down less than 6 hours. Likewise, in every wire, there is a fixed delay. Fiber optics, there will be delay. Ethernet wire, that will be delay. But fiber optics delay will be little lesser than the Ethernet. Like you have, in aeroplane, there is a delay. 15 minutes it will take for you to go from Bangalore to Chennai. So that is the delay. Can you reduce the delay 15 minutes to 10 minutes? Not possible. So it has to take off and land. Taking off time, landing time, acceleration time. So I just told 15 minutes. Actually, 15 minutes is a flight time, but takeoff and landing, you need to add another 30 minutes actually, or at least another 15 minutes. So 30 minutes, even if it is a very big flight, 30 minutes it will take Bangalore to Chennai. You cannot go less than that. 25 minute no, not possible. 29 minute, even that is also not possible. In aeroplane, 1 minute is matter, big matter. So delay is always there. Whether you go in a jet plane or in an aeroplane or in a bus or matavandi, there will be always one delay. For every vehicle, there is a fixed delay. But the reliability changes. Reliability. See, morning, every morning, most of us go office. I hope so. 100 feet road. Everyone is going to office, Asim. So the peak hour between 7:30 a.m. starts in most of the cities, and till it will go 10:30 a.m. Those time load is high, so reliability is less. You don't trust that road. I cannot guarantee, man. If you go in between, if you go at 8:30 and all, I cannot guarantee that you will go to office on time. See, unreliable. The reliability goes down when there is a heavy load. But early morning, 5 o'clock, same road, you can tell you start now at 5 o'clock. 5:20 will be in your place. You can give that reliability. But as the traffic increases, means as the load increases, the reliability on that path get decreased. MTU, maximum transmission unit. What does that mean? In this 100 feet road, how many lorries at a time can go? 1, 2, 3, 4, 5, 6 lorries at a time. Can I have seventh lorry? Not possible. That's the maximum lorry. In this 100 feet road, how many autos can go at a time? Maybe 14 autos. Can I have more than that? Not possible. 14 autos. This is what called as maximum transmission unit. Now, bandwidth is fixed at 100 MB. Delay is fixed for 100 MB, there will be a fixed delay. For 1000 MB, there will be less delay. Again, that is also fixed. But load, time to time it will change. So if someone is downloading a big movie, then load will be high, reliability will be less. When someone finishes the download, reliability will go high and load will come down. But this bandwidth, delay and MTU will never go up and down. It is fixed for a link. For every link, there is a fixed amount of bandwidth and load and delay. Sorry, bandwidth and MTU. So what they did in EIGRP is they made only K1 and K3 as a metric. They removed these three from the metrical consideration. Listen, we have this 5 metric in EIGRP, but they are not considered. Only 2 are considered. What are they? K1 and K3. K1 and K3. Only these are the 2 things considered. K1 and K3. You're buying a pen. What do you will expect from a pen? The pen should be cute looking pen, good color, and it should write. Only these are the 3 qualities I look for when I buy a pen. It should look nice and it should be cute, meaning it should not be too big like a Aringer Anna pen. Who wants that pen? Cut a pen. I don't want. I want slim, sleek pen which I can hold for a long time and write, which is not heavy. That's what I mean. Cute pen, nice color, and it should write. That's all. Those are the 3 main things we will see. But a pen may also have a watch. A pen may also have a camera in it. See, those are all additional, not a mandatory feature of a pen. Likewise, these are all additional, not a mandatory metric of a routing protocol. Fine, EIGRP's metric is bandwidth and delay. That's all. Next, administrative distance of EIGRP is 90. EIGRP can support equal cost path as well as unequal cost path. What does it mean? Let's say for you to go from A to B, if you go via this router 2, The bandwidth and delay, let's say composite value, both bandwidth and delay, here it is 10, here it is 15. This link. In this link, it is 17 and here 12. This is what unequal cost. If you go this way, what is the total cost? 25. If you go this way, what is the total cost? 29. Which one is lower? This is lower. This is cheaper. So this is the preferred path, primary. And now EIGRP can maintain a backup path. No other routing protocol maintains backup path. When I say other protocol, I mean distance vector protocol. OSPF maintains backup path in the link state database. Here EIGRP maintains backup path in the topology table, but what EIGRP can do is, where other protocols can't do this one, what? Unequal cost load balancing. Now very detailed study about these things are coming in the next level, CCNP level, with a very nice lab. So you can share load between A and B via both the path. Primary means via router 2 as well as router 3. So instead of keeping primary and backup, you can have both as primary, even though the cost is not same, which is what called as unequal cost load balancing. In EIGRP, it is possible. Whereas the other protocols, like OSPF, RIP, they do only support equal cost load balancing. They support only equal cost. Only EIGRP supports unequal cost load balancing. And EIGRP will send hello packets every 5 seconds. And using the hello packet, two routers will know about each other. See, this router knows about this router because they send a hello packet. That helps this router to discover the neighbor. Once the neighbor's discovery is done, they share the routes that they have. So hello packets are important for neighbor discovery. Not only that, they're also important to maintain neighbor. See, after forming neighbor, what if this goes down? You should know. So it will keep sending hello packet that gives the guarantee that the router is still alive. Hello packets are sent every 5 seconds. Now, after forming neighbor, if a router don't send hello for 15 seconds, the neighbor is considered dead. Dead time. Hello time is 5 seconds in EIGRP. Dead time is 15 seconds. Now, EIGRP uses 224.0.0.10 as the multicast address. This is the address that will be used by hello packets to send the hellos. Not only that, when there is an update that need to be sent to all EIGRP router, not just one neighbor, to all neighbors, then 224.0.0.10 will be used. Right, these are the main things that we saw in the previous class. So we are going to do a small lab to know how to configure EIGRP. See, EIGRP is again a big topic. A detailed EIGRP comes in our next CCNP. Now we got 3 routers. Here what I'm going to do is I'm going to have a loopback interface. Loopback interface is nothing but a logical interface where I put some IP address as if I put it on a physical interface. This loopback interfaces will respond if I ping. Same like what a physical router, physical interface can do, this virtual interface can also do. These are the IP address that I'm going to have on the router. Let me name this router as router 1. This is router 2. This is router 3. Now between these routers, I'm going to have 10.0.0.1/8 8. So this is what the IP address plan that I have to configure. After I configure IP address, I'll enable EIGRP. And your homework for tomorrow is same lab. You need to repeat the same lab in your home. What I am doing is what need to be repeated. Same IP address. So from today onwards, you will have labs to do at home also. That's a homework. I'll call this as router 1, interface loopback 0. So it's a virtual interface I create. And I put an IP address 101.1. This is not a mandatory one. Configuring loopback interface is not mandatory. I just want to have an additional network. Instead of connecting a wire, I'm just creating a virtual wire here so that I can put an IP address. Fine, next. Interface F0/0, no shit. IP address 10.0.0.1. That's it. So this router is now ready. Show IP interface brief. You can see this is the virtual interface I created. And I have given IP address. Same like, as I given an IP address on the physical interface, I am able to give an IP address on the virtual interface. இல்ல ஆனா இருக்கு. இருந்தா எப்படி ஒரு ரிப்ளை வருமோ, யாராவது பிங் பண்ணாங்கன்னா இந்த அட்ரஸ் தூரத்துல இருந்து பிசிக்கல் இன்டர்ஃபேஸ் பிங் பண்ணா எப்படி ரிப்ளை பண்ணுமோ அதே போல ரிப்ளை பண்ணும். So even though it is physically not there, there is no port called loopback 0 physically, but there is one port called F00 physically, but there is no port called loopback 0. Even though there is no port called loopback 0, you can still ping this address and you will get reply as if there is an interface. So இல்லாத ஒரு நெட்வொர்க், சரி, ஒரு நெட்வொர்க் எனக்கு தேவை 1.1.1.1, அந்த அட்ரஸை கொடுக்கறதுக்கு இன்டர்ஃபேஸ் என்கிட்ட இல்லைன்னா நான் இப்படி ஒரு இன்டர்ஃபேஸ் கிரியேட் பண்ணிக்கலாம். எனக்கு அந்த ஒரு அட்ரஸ் வேணும் அந்த ரவுட்டர்ல. சரி, let's move to the second router. Even in this router, I'm creating a loopback interface with an IP address 2222 and some complete mask 32. And then interface F0/0. See, I was inside loopback interface. I can straight away go to physical interface without exiting out. You don't need to exit and then go into another interface. Straight away you can go. Okay, on F00, the IP address is 10.0.0.2. Now let's bring up the last router and put the IP address. Host name router 3. Interface F0/0. I don't know whether I gave IP address on this interface F01 here. No, I have not. Interface F0/1. No shit. 20.0.0.1. All right. So on router 2, when I type show IP interface brief, I should see 3 interfaces, including this virtual interface. And on router 3, I should see 2 interfaces. One physical interface and state is up, and one virtual interface, which will be automatically up because you only created it. On loopback interface, there is no need to say no shutdown when you configure. Anyway, we got the IP address in place, but what we don't have is we don't have route to reach 10 network, 2.network, 1.1.1 network. We don't have a route to reach 2.2.2.2, 1.1.1.1 and 10. Likewise, on router 2, if you check, you don't have a route to reach 3.3.3.3.3 and 1.1.1.1.1. Likewise, on router 1, if you check, you don't have route to reach 2.2.2.20.3.3.3, which are not connected directly. So we need to run now a routing protocol. And we have chosen to use EIGRP. So let's do EIGRP. Router EIGRP, you need to give a number. And this number that I'm going to give here need to be same on all other routers. Only then they can form neighbor. They all need to be in single autonomous system. And the autonomous system number that I wish to use is 200. You can give any number between 1 to 65535. I'm giving 200. And then as usual, we need to say network 1000, network 10.0.0.0. Let's go to the second router. Router EIGRP 10. Sorry, what is the number I gave here? 200. Router EIGRP 200. Network 2.0.0.0. Network 10.0.0.0. Sorry about this. Network 20.0.0.0. On router 3, router EIGRP 200, network 3000, network 20.0.0.0. That's all. You will have now a neighbor. I think I made a mistake in router 2. Show IP interface brief. Here also I have given same to .2. Actually, it's supposed to be .1. It should be .1. So on router 3 and router 2, I have given same address or config. Now neighbor has come. Now, if you go to router 3 and check the routing table, you will have all the routes. See, there is a neighbor. Show IP EIGRP neighbor. This is the neighbor. Whose address is this? Router 2. If you go to router 2 and check who are your neighbors, show IP EIGRP neighbor. It says I got two neighbor. One is router 1, the other one is router 3. This is router 3's address. And now if you go to router 1 and check the neighbor, show IP EIGRP neighbor, you have one neighbor. There is another table called show IP EIGRP topology. It will show all the networks in this topology. See all the networks. Now you can check the routing table. So you got the root. D means dual algorithm. EIGRP uses dual algorithm. So D means learned through EIGRP. And you got 2 network, 3 network, 20, all the networks. So I can ping from here this last loopback of router 3. What is that? 3.3.3.3. See, I'm able to ping. If you want, you can trace route and see. You can see that traffic will go through router 2. So it goes to 10.2, which is router 2, and then it goes to router 3, which is 23. Right? This is the beginner level of EIGRP. But there is a big detailed story of EIGRP coming in next level. When you join CCNP, you will be learning that. So what I want to say is, this level at least you should know very well before you go to next level. Learn this and come. And tomorrow we are going to start with ACL. Any question on what we learned today?